All right, let's get right into it. What if I told you our solar system had a visitor? Not some alien spaceship, but something almost more incredible. A real-deal traveler from a distant, unknown star, carrying secrets about our galaxy's ancient past. Well, it happened, and this is the story of that visitor, the interstellar comet 3I/Atlas. I mean, just think about that for a second. What if we got a message, but it wasn't a radio signal or some kind of code? What if it was a physical object, a literal message in a bottle sent across light years, just waiting for us to find it and figure out what it has to say? Well, this is it. This is what that message looked like. This incredible, ghostly cloud you're seeing is 3I/Atlas in a stunning shot from the James Webb Space Telescope. That's not just a rock, you know. That's an active, living piece of another solar system that just happened to swing through our cosmic neighborhood. So, our story kicks off on July 1st, 2025. The Atlas telescope in Chile spots a new object. It's faint, but man, is it moving fast. So fast, in fact, that it was pretty quickly labeled 3I, which stands for the third confirmed interstellar object we've ever seen. And this number is the dead giveaway, 58 kilometers per second. That's its hyperbolic excess velocity. Now, in plain English, that means even after you account for the sun's massive gravity pulling on it, it was still screaming along at that speed. That's just way, way too fast for anything born in our solar system. This thing wasn't in orbit, it was just passing through. A true interstellar tourist. So, once we knew it was from out of town, the next big question was, what exactly is it? Is it just a dead piece of rock? An asteroid like our first interstellar visitor, Oumuamua? Or is it an active icy comet, like the second one, Borisov? This was the first major clue they had to nail down. And just so we're all on the same page here, an asteroid is basically a space rock. It's inert. A comet, on the other hand, is more like a giant, dirty snowball. When it gets close to a star, those ices vaporize, they turn straight to gas, and create that beautiful glowing cloud around it called a coma. One is quiet, the other is very much alive. But here's the thing, at first, nobody was sure. Some of the most experienced astronomers on the planet looked at it and saw nothing but a tiny point of light. The object was really keeping its cards close to its chest. Was it just a boring old rock after all? But then, as more and more telescopes started to point in its direction, a different story began to emerge. People started reporting that the point of light, well, it wasn't so sharp. It was a little fuzzy. There was a faint glow around it. And that, right there, is the telltale sign of an active comet. And you can just watch the evidence pile up in real time. On July 2nd, one telescope sees a marginal coma. Okay, interesting. Another sees a potential tail-like elongation. Then, just 2 days later, the giant Very Large Telescope gets a look, and the verdict is in, a distinctly fuzzy appearance. That's it. Case closed. 3I/Atlas was, without a doubt, a comet. Okay, so we know it's a comet. Now the real fun begins. With its identity locked in, it was time to put this thing under a cosmic microscope. Time for a complete forensic deep dive to figure out everything we possibly could about this amazing traveler. Let's talk about its path for a second. This number, 6.139, is its orbital eccentricity. A perfect circle is 0. Earth's orbit is super close to 0. An eccentricity over 6? That's not an orbit. No way. That's a cosmic flyby. It came screaming in, whipped around the sun, and shot right back out into deep space, never, ever to return. And get this, despite that bright, beautiful glow, the solid chunk of ice and rock at its heart, the nucleus, was tiny. It was estimated to be less than a kilometer across. It's just a great reminder that the amazing sight of a comet comes from that enormous cloud of gas and dust, which can be hundreds of thousands of kilometers wide, all blasting off a tiny little core. So you might be wondering, how on earth do you figure out what that gas cloud is made of from millions of miles away? Well, you use this amazing technique called spectroscopy. It basically splits the light from the comet into a rainbow, and every single molecule, water, carbon dioxide, whatever, leaves a unique pattern, like a chemical fingerprint. And when the James Webb Space Telescope read this comet's fingerprint, whoa, it found something truly shocking. The gas pouring off this thing wasn't mostly water, which is what we see in comets from our own solar system. No, this was almost 88% carbon dioxide. This was a totally different kind of animal, a huge clue that it formed in a very, very different place than our own comets did. So let's recap. We've got a super fast carbon dioxide-rich comet on this wild, unbound trajectory. All of these clues were fascinating, but they all pointed to the single biggest question of all. Where in the vastness of the Milky Way did this thing actually come from? To figure that out, astronomers did something that just sounds like science fiction. They took its speed, its direction, and they basically hit rewind on the entire galaxy, tracing its path backwards through space for billions of years to see where it started. Now, to really get what they found, let's look at the path of the last interstellar comet, 2I/Borisov. That's the orange line. See how it stays pretty close to that flat main disk of the galaxy? That's called the galactic plane. Our sun, in blue, does the same thing. This suggests Borisov came from a relatively young star system, kind of like ours. But 3I Atlas, its path was completely different. As this research puts it, it showed significantly larger vertical excursions. It wasn't sticking to the flat plane at all. It was soaring high above and diving deep below it. And that kind of wild, looping orbit, that's the hallmark of really, really old stars from what we call the thick disk of the galaxy. And that thick disk isn't just a place, it's a time. It's home to ancient stars that were born during our galaxy's cosmic noon, this incredibly chaotic time about 9 billion years ago when stars were forming like crazy. This means 3I Atlas isn't just from another star system. It's very likely a pristine relic from the galaxy's youth that's been wandering the void for billions of years. So after billions of years of travel, this message in a bottle finally arrived. Let's unpack it. What did this tiny visitor actually teach us about our galaxy? Well, first and foremost, it's a physical sample from the galaxy's cosmic noon. I mean, that's incredible. Its crazy carbon dioxide-rich nature gives us a direct peek into how planets formed in a totally different, ancient environment. It strongly suggests that the basic building blocks of life in planets, carbon, oxygen, nitrogen, are probably common all across the galaxy. And maybe most importantly, it proves that these ancient wanderers are really out there. Really, the best way to picture 3I/Atlas is as a time capsule, not one you bury for a few decades, but one that's been traveling for billions of years, a perfectly preserved sample from a star system that might not even exist anymore, delivered right to our doorstep. And all of this leaves you with one last kind of mind-blowing thought. 3I/Atlas was only the third visitor like this we've ever managed to spot. So it really makes you wonder, doesn't it? How many more of these ancient messengers are flying through our solar system right now, completely unseen, just waiting to share their stories from across the stars?